Welcome to our podcast, where we cover unique and interesting stories for you. In this episode, we will discuss a study suggesting that intermediate mass black holes may have a birthing nest in the cosmos. In new research, scientists have found that elusive intermediate mass black holes may have birthed in dense star clusters, which are filled with tens of thousands to millions of tightly packed stars known as globular clusters. The mass of an intermediate mass black hole is between 100 and 10,000 times that of the Sun. They are heavier in comparison to solar mass black holes, which have a mass that ranges between 10 and 100 solar masses, and still, they are lighter in comparison to the supermassive black holes. The supermassive black holes have a mass which is equal to millions or even billions of suns. The astronomers found that these cosmic in-betweeners were elusive in 2012. The intermediate mass black hole, which has been named GCIRS 13e, has a mass which is 1,300 times that of the Sun and is situated 26,000 light-years away. It is located near the galactic center of the Milky Way. The surroundings in which the intermediate mass black holes have been formed have always remained a mystery. The birth of stellar mass black holes happens when massive stars collapse, and the growth of supermassive black holes happens after subsequent mergers of larger black holes. According to astronomers, a star which is massive enough to die and form a black hole with thousands of solar masses is incredibly rare, and it must struggle to retain its mass when it is dying. To understand how these intermediate mass black holes are formed, the first ever star-by-star simulation of massive clusters was performed by a team of researchers. In the experiment, it was observed that a dense enough molecular cloud birthing nest, which consists of globular clusters, may have led to the creation of stars which are huge enough to collapse and release an intermediate mass black hole. In a statement, University of Tokyo scientist and team leader Michiko Fujii said, "Previous observations have suggested that some massive star clusters, globular clusters, host an intermediate mass black hole. So far, there has been no strong theoretical evidence to show the existence of intermediate mass black hole with 1,000 to 10,000 solar masses compared to less massive and more massive ones," he added. "Our final goal is to simulate entire galaxies by resolving individual stars. It is still difficult to simulate Milky Way-sized galaxies by resolving individual stars using currently available supercomputers. However, it would be possible to simulate smaller galaxies, such as dwarf galaxies," Fujii further explained. That's all from this podcast. Thanks for tuning in. If you enjoyed this episode, be sure to subscribe and share your thoughts in the comments. Stay connected for more exciting discussions and updates in our next podcast.